In this video, I'm going to show you a few techniques that most beginners have never heard of. Let's get started. The first technique is called edge slide. Let's take a plane as an example. Extrude this edge and give it a slight angle. If we press G twice, we activate the edge slide tool. A blue line appears. It's a visual indicator showing how far we can slide the edge along its local axis. By default, you can only slide the edge along the blue line. If you press Alt or C, you can deactivate the clamp function and the blue line becomes infinite. This allows you to slide the edge along its local axis infinitely in both directions. This technique is extremely practical and we will see why in the next example. Second technique, custom pivot points. I have this mesh and I want to reconstruct the bottom right corner. When the mesh is perfectly aligned with the X and Y axes, the simplest and fastest method is to use the snapping tool set to vertex, enable auto merge vertices, then snap the vertices like this. When the mesh has a rotation value but the transforms haven't been applied, meaning Blender remembers the rotation value, the easiest way is to use the local pivot point so that the axes are correctly aligned. The mesh was rotated by -28.2 degrees and the pivot point as well. Then we just snap the vertices the same way as before. Now let's make it more complicated. We are going to apply the rotation values. This means Blender no longer has any rotation informations, so we can't use global or local axes anymore. To fix this, we will use a custom pivot point. We want the pivot point to be oriented in the direction of this edge. To do this, select this edge, open the Transform Orientations menu and click on this little plus icon. This will orient the gizmo in the same direction as the selected edge. We snap the vertices as we did before. However, it doesn't work on the other side because the pivot point depends on the orientation of the bottom left edge, which is different from the right edge. You would have to create a new pivot point by repeating the operation. This technique is useful in most cases, but in this specific example, it requires more steps and takes a bit longer. Let's look at another method you already know, edge slide. This is the method we used in the very first example of this video. It's great because it allows you to make the same modifications without worrying about pivot points or the mesh's orientations. Simply press GG, then Alt or C and snap the vertices. And the last method is using the shortcut Shift numpad 7. This aligns the viewport camera to the normal of the selected face. When I press this shortcut, my viewport rotates so the face is perfectly aligned with the X and Y axes. Set the pivot point to view, then all that's left is to snap the vertices. You can download my beginner 3D modeling ebook called Mastering Topology and Hard Surface Modeling. It includes tips and tricks to work faster and more efficiently, the most common mistakes beginners make and how to fix them, and many other helpful insights. 13 years of experience gathered in one place. The link is in the description. The next technique is called Extrude manifold. Watch what happens when we extrude faces at a corner. You can see overlapping faces, noticeable by the visual glitches in the viewport. The problem with a classic extrusion like this is that we have to delete all the faces, which leaves us with a hole and floating vertices. We're forced to create edge loops and merge vertices to fill the hole. It's time consuming and not the optimal way to create this kind of detail. Here's how to do it more cleanly. Select the faces, press Alt E and choose Extrude Manifold. This extrudes the faces while keeping the geometry closed. We can easily add a bevel and connect the vertices like this for a clean result. The final technique I will show you in this video is how to consistently find the right number of edges for a Boolean operation. When using Booleans, the target object and the cutter object should have similar polygon densities, but finding the right value by guesswork isn't always easy. We can see the cutter's density is higher than the target object. First, I'm going to select only these edges, which represent the cylinder's silhouette. I invert the selection with Ctrl I, then delete the edges. I do the same for the cutter object, and I'm left with two profiles. I will use a modifier to recreate my cylinders from these edges, but it depends on the location of the origin point. Since it's perfectly centered, we're good. The modifier will recreate the geometry circularly around the origin. That modifier is the screw modifier. It allows us to control the number of sides using the steps viewport parameter. Let's give the large cylinder a value of 32. Then we do the same for the small cylinder. Ideally, you want a value that matches the density. Here, 16 is the correct value. You will notice the edges are not aligned correctly. We need to add a rotation to the small cylinder, but how do we find the exact value? You divide 360 degrees by the number of sides, which gives you 22.5, then divide that by 2, which gives you 11.25. So if I press RY 11.25, my edges are perfectly aligned. Apply the screw modifiers. Now just add the Boolean modifier, delete the center faces, enable snapping and auto merge vertices, and connect the edges and vertices cleanly. You can use a mirror modifier to speed things up, add a bevel, and your 3D model's topology will be perfect. If this video taught you something new, please consider subscribing. It's free and you can always change your mind. Thanks for watching.